Hi, welcome to Nepal Digital Education. Today in this video series, we are going to start the numericals of simple machine of class 8. Before solving the numerical problem, we must understand the some terms like simple machine, complex machine, load, effort, fulcrum, lever, and so on. So first term is simple machine, and simple machine is something that makes our work easier, faster, and more convenient. That is called simple machine. Like example, scissor, nail cutter, wheelbarrow, stapler, fishing rod. These all are the example of the simple machine. And complex machine means something that made up of two or more simple machine. That is, let us take example, bus, truck, washing machine. These all are example of complex machine. Complex machine means machine which is made up of different type of simple machine. That is called complex machine. But before solving this numerical problem, we must have idea about the lever. So lever is a rigid bar or rod that can move freely around a fixed point. That is called lever. Let us look at the figure. This is this horizontal line is called rod. This horizontal line is called rod, rigid bar, or we can say lever. Lever, this is called lever. This is lever. And lever, we can define lever is a rigid bar or rod that can move freely around a fixed point. From this fixed point, it moves. So this is called lever, and lever has three main parts. That is load. This is load, effort, and fulcrum. These three main part of the lever. Load. This load means weight of an object, and effort means force applied, and fulcrum. Fulcrum. This fulcrum is a fixed point. This fixed point. Fulcrum means fixed point around which the lever moves. So simply we can say that load means weight of an object. Weight of an object. Effort means force applied. Fulcrum means fixed point. Fixed point around which the lever moves. This is called lever, and there are three types of the lever: first class lever, second class lever, and third class lever. And we can also define easily first class lever, second class lever, third class lever. We can easily define this type of the lever just by one trick. Flee is the trick. F first class, L second class, E third class. Means we can define first class lever. First class lever is a type of the lever in which fulcrum is situated between load and effort. And we can define second class lever. Second class lever, the type of the lever in which load is situated between fulcrum and effort. That is called second class lever. And third class lever means the type of the lever in which effort is situated between fulcrum and load. That is called third class lever. This is the trick. Flee is the trick. With the help of this trick, we can define first class lever, second class lever, and third class lever. Let us look at the problem first. In problem first, we have a 1200 Newton load. So load is given. It is to be lifted with 200 Newton effort. This is effort using a first class lever. At what distance from the fulcrum must the effort be applied when the load is 15 centimeter away from the fulcrum? So before solving this numerical problem, we must know about the load distance and effort distance. Load distance means the distance between load and the fulcrum. distance between load and the fulcrum, that is called load distance. And effort distance means distance between fulcrum and effort. Distance between effort and fulcrum is called effort distance. So it is very necessary to understand about the load distance and effort distance. So in this problem we have load 1200 Newton. This is the load, and we have effort 200 Newton, and load distance we have load distance 15, and we have to find the effort distance. We have to find the effort distance. Like in this problem, 1200 load. So this load is given 1200 Newton and lifted with 200 Newton effort. Effort is 200 Newton. Using a first class lever, at what distance from the fulcrum? At what distance from the fulcrum must the effort to be applied when the load is 15 centimeter away from the fulcrum? Load is 50 centimeter away, means this load is 15 centimeter away from the fulcrum, means load distance is given. We have to find the effort distance. So we have formula load into load distance equal to effort into effort distance. Just by using this formula only, we can solve all the numericals related to lever. So load into load distance equal to effort into effort distance. This is the principle of the lever. This is the principle of the lever. Principle of lever. This is the principle of the lever. By using this principle, we can solve any type of numericals related to the lever. So load is given 1200, load distance 15, effort 200, effort distance we have to find the effort distance. 1200 into 15, it is in multiplication, so when it comes this side, it comes in division, become effort distance. Just solve it. When we solve, just multiply 1200 into 15 and divide with 200, then we get 90. Then effort, so effort distance equal to 90 centimeter. So this is the required effort distance. So in this problem, the required effort distance is 90 centimeter. Let us look at the problem second. Calculate the magnitude of effort from the given diagram. In given diagram, we have load on 800 Newton, and effort we have to find the effort here. Load is given 800 Newton, load distance 50 centimeter, effort distance 150, and we have to find the effort. So first of all, write the given, and given is load is given 800 Newton, load distance is given 50 centimeter. We have to find the effort, and effort distance is given 150 centimeter. So we have principle of lever. Just by using principle of the lever, load into load distance equal to effort into effort distance, we can solve any type of the problem related to the lever. So load is given 800, load distance 50, effort we have to find the effort, and effort distance is 150. So 800 into 50 divide 150. It is in multiplication, so it comes in division, and this is effort E. So just multiply it 800 into 50 and divide with 150, then we get the value 266.66 equal to E. So effort is 266.66. effort means force applied, so unit of force is Newton. So if effort is 266.66 Newton, 266.66 Newton, this is the required effort. So in this diagram, effort, the magnitude of effort is 266.66 Newton. Let us move to the next problem, problem number 3rd. In this problem, a crowbar with length 200 centimeter, length is 200 centimeter, is used to lift a load of, load is given 600 Newton. If the distance between fulcrum and load, distance between fulcrum and load, so load distance is given, calculate the effort, MA, VR, efficiency. So crowbar, first of all, this crowbar is the example of first class lever. So we know that in first class lever, fulcrum is situated between load and the effort. Suppose this is one load, here effort is applied. So crowbar length, total length means total length is given 200 centimeter. Load of 600, load is given 600 Newton. If the distance between fulcrum and load, distance between fulcrum and load is given 0.75 meter. Calculate the effort. We have to find the effort, MA, VR, and efficiency. We know that 200 centimeter means 2 meter. So this load distance is 0.75 meter. So this become 1 point, calculate 2 minus 0.75, it become 1.25 meter. So we have total length is given 200 centimeter. 200 centimeter means 2 meter. If the load distance is 0.75 meter, then total length equal to load distance plus effort distance. Our length is given 2 meter, this load distance 0.75 plus effort distance. In this way we can find our effort distance. So when we calculate it, then we get here 1.25 equal to effort distance. So effort distance become 1.25 meter. So our effort distance is given, load distance is given, and load is also given. Then we have to find the first of all effort. So in case of the lever, just by using principle of the lever, we can find the effort. So in first we have to find the effort. Just by using principle of the lever, we can find the effort. Now by using principle of the lever, load into load distance equal to effort into effort distance. So we have load is 600 Newton, and load distance is given, load distance 0.75. Load distance is given 0.75 equal to effort. We have to find the effort, and effort distance is given 1.25. So 600 into 0.75, it is in multiplication. So when it comes this side, it comes in division. So when we calculate it, 600 into 0.75 divide 1.25, we get 360. 360 equal to E. E means effort. Effort means force applied. The unit of the force is Newton. So it become 360 Newton. So this is the required effort. And in B, we have to find the YMA. YMA means mechanical advantage. Mechanical advantage. And we know that mechanical advantage YMA is equal to given by load by effort, and load is 600 Newton. Load is 600 Newton. Effort is 360. When we divide 600 divide 360, it becomes 5 by 3, or we can also write 1.67. This is the required answer. And in C, we have to find VR. VR means velocity ratio. We have to find the velocity ratio, and velocity ratio is given by effort distance by load distance, and we have effort distance is 1.25. Effort distance is 1.25, and load distance is 0.75. When we divide 1.25 divide 0.75, then become 5 by 3, or we can also write 1.67. This is the required VR, velocity ratio. Again, in D, we have to find the efficiency. In D, we have to find the efficiency, and efficiency denoted by eta. This is the symbol of eta. Efficiency equal to YMA by VR into 100. And YMA is 5 by 3, VR is 5 by 3 into 100. And efficiency is always calculated in percent. So 5 by 3 cancel, it become 100%. So efficiency is 100%. This is the required effort YMA VR efficiency of the crowbar. So here efficiency means how much work is done by the machine, and we can calculate efficiency just by using this formula YMA by VR into 100. So our required efficiency is 100%. Let us move to the next problem number 4. In this problem, we have an effort of 500 Newton. So effort is given here 500 Newton. Effort is given 500 Newton was applied to lift a stone of 1000 Newton with a crowbar. Crowbar means first class lever. Calculate the mechanical advantage of simple machine. In which direction should the point be shifted to increase the mechanical advantage? So in this problem, we have to find the YMA mechanical advantage. And we know that YMA mechanical advantage means load upon effort. If we have load and effort, we can easily find the YMA. So in this problem, we have given here effort 500 Newton was applied to lift a stone of this much. So this is effort and this is load. Then we can easily find the YMA. YMA means mechanical advantage. So first of all, write the given, and given load is given, so load is given 1000, load is given 1000, and effort is given 500. We know that yum is given by load upon effort, and load is given 1000, effort is given 500. So calculate it, 0 0 cancel, 5 2 are 10, 2. So yum is 2. This is the required mechanical advantage of the simple machine. But in B, in which direction should the point be shifted to increase the mechanical advantage? So we know that crowbar is the example of the first class lever. In first class lever, fulcrum is always situated between middle of the load and the effort. Suppose this is load, this is fulcrum, and this is effort. Because crowbar is the example of first class lever, and we know that first class lever means fulcrum is situated between, this fulcrum is situated between load and effort. In question number B, we have in which direction should the point be shifted to increase the mechanical advantage. So to increase the mechanical advantage, in which direction should the point be shifted to increase the mechanical advantage? So to increase the mechanical advantage, yes, to increase the mechanical advantage, just moving the load, this load closer to the fulcrum and effort farther away, this effort farther away from the fulcrum. In this way we can increase the yum. If you want to increase the mechanical advantage, then there is two steps. If we move the load, toward the fulcrum, and this is what effort, when we move this load toward the fulcrum and when we move this distance away from the fulcrum, then we can increase the mechanical advantage. So we can say that mechanical advantage is increased by moving the load closer to the fulcrum and effort farther away from the fulcrum. In this way we can increase the mechanical advantage. Let us look at the next problem. Problem number 5. In this problem, we have a simple machine which has mechanical advantage. We have mechanical advantage yum, velocity ratio VR. Calculate the efficiency of the simple machine. It is so easy. Here yum is given, mechanical advantage is given 4, velocity ratio is given 5, and we have to find the efficiency denoted by eta. We have to find the efficiency, and we know that efficiency is given by yum by VR into 100, and always efficiency calculated in percent. And we know that efficiency means how much work is done by the machine. So efficiency always calculated in percent, and we have yum for VR 5 into 100. Just solve it. 5 2 are 10, 20 2 are 24 are 4 means 80. It become, when we multiply 4 into 100 and again divide with 5, then we get 80. So 80%. This is the required efficiency of the simple machine. So in this way we can find the